So, GCSE AQA Chemistry, topic 5 today, I believe, on endothermic and exothermic reactions, bond energy calculations and an energy transfer practical, cells, batteries and fuel cells. Topic 5, Energy Changes. Conservation of energy means energy always flows from one form to another during chemical reactions. If there is an excess or a deficit of energy, this is taken from/given to the surroundings. Exothermic reactions transfer energy to the surroundings through the form of heat, i.e. a rise in temperature, e.g. burning fuels, neutralization reactions, and some oxidation reactions. This is seen in everyday life with campfires and hand warmers. Exothermic reactions, however, take in energy from the surroundings, causing a drop in temperature. They are much less common, only seen in thermal decomposition and citric acid with sodium hydrocarbonate. This is usually found in sports injury packs, which do not need to go in the freezer. One practical related to this is energy transfer. This can be measured by measuring the temperature of the reactants and the products and finding the difference, trying to lose as little heat as possible. This can also be compared to different variables to find their effect on the amount of energy transferred. Step 1. 25 centimeters cubed of 0.25 mole per decimeter cubed hydrochloric acid and sodium hydroxide into different beakers. Step 2. Put in water bath at 25 degrees until they're both the same temperature. Step 3. Add both to a polystyrene cup with lid inside large beaker of cotton wool. Step 4. Measure temperature every 30 seconds and record the highest temperature. Step 5. Repeat using 0.5 mole per decimeter cubed and then 1 mole per decimeter cubed of hydrochloric acid. During reactions, bonds are broken and formed. Bond breaking is endothermic, and bond making is exothermic. In exothermic reactions, the energy used to break the bonds is less than the energy used to make them, and endothermic reactions vice versa. Reaction profiles can show whether the reaction is endothermic or exothermic. In these diagrams, the initial flat line is the energy of the reactants, and the final flat line is the energy of the products. The initial line going upward is called the activation energy, the energy used to break the bonds, and the downturn the energy used to make them. When the products are at a lower energy level than the reactants, the reaction is exothermic. If not, the reaction is endothermic. The difference between the products and the reactants is the energy made/used. It's called triangle, delta, H. The x-axis is time, and the y-axis is the energy per mole. Bond energy calculations need to be practiced because they will almost definitely come up in exams. Every chemical bond has a specific bond energy. These can vary slightly and will always be supplied in an exam unless you need to find one, so don't bother learning them. These bonds in reactions can be added up/taken away to find the overall energy change for the reaction. E.g., the overall energy change for H2 plus Cl2 makes 2HCl. The H bond is 436 kilojoules per mole. The chlorine bond is 242 kilojoules per mole. And the hydrogen-chlorine bond is 431 kilojoules per mole. So first you find the energy required to break the bonds. The HH bond plus the Cl-Cl bond, which is 436 plus 242, comes to 678 kilojoules per mole. The energy released with the products is 2HCl, so 2 times 431, which is 862 kilojoules per mole. The overall energy change is the reactant's energy minus the product's energy, which in this case is 678 minus 862. Which is minus 184 kilojoules per mole. The minus number means the reaction is exothermic. To compare the overall energy changes, you will need the data from both reactions. Never try to guess. A cell is a chemical reaction similar to electrolysis, covered in the previous topic. It has two electrodes in an electrolyte. The electrodes are usually metals, so they can conduct electricity. The electrolyte has ions that react with the electrodes to make a charge difference between them. If they are connected by a wire, the charge flows so electricity is produced. A voltmeter can also be connected to the circuit to measure the voltage of each cell, e.g. copper and zinc electrodes with a sodium chloride electrolyte. The bigger the difference in reactivity of the metals, the larger the voltage there is going through the cell for the same electrolyte. E.g. iron and tin produce a voltage of minus 0.30, but iron and lead produce minus 0.31. The electrolyte also has an effect on the size of the voltage. A battery is formed by connecting multiple cells together, so the voltage overall is bigger. In non-rechargeable batteries, the chemical reaction is irreversible, so once the chemical reaction is finished, no more electricity is produced. This is the case with most normal AA or AAA batteries. In rechargeable batteries, the reaction can be reversed by connecting it to an external electric current. A fuel cell uses fuel and oxygen to produce electrical energy through the heat made by oxidizing the fuel and creating a voltage within the cell. There are a few different types, e.g. hydrogen-oxygen fuel cells, which produce water and energy. Fossil fuels in vehicles are a finite supply which we are burning through at an alarming rate, destroying the environment along with it. A solution to this is electrical energy. Batteries could be useful, but hydrogen-oxygen fuel cells might be better and more practical. Because they don't produce pollutants, only water and heat, electrical batteries used in cars are difficult to dispose of safely due to toxic metals in them. And the car battery can't be recharged forever, so they are also more expensive than fuel cells and store less energy, taking more time to recharge afterwards. Hydrogen-oxygen fuel cells involve a redox reaction. Inside the cell, the electrodes are porous carbon plus a catalyst, and the electrode is potassium hydroxide. Hydrogen goes into the anode compartment, and oxygen goes into the cathode compartment. At the anode, hydrogen is oxidized, H2 plus 2H plus 2E minus, or H2 makes 2H plus 2E minus. The H plus ions that move to the cathode where it is reduced with oxygen and electrons to make water. O2 plus 4H plus 4E minus makes 2H2O. The H plus ion flow creates an electric current, and the overall reaction is hydrogen plus oxygen makes water. Don't forget guys, the link to the mind map is down in the description box below. Don't forget to like and subscribe to my channel for more chemistry and GCSE revision videos. Comment any questions down below and I will see you in the next one.